All right, so we are recording. I checked the sound, and hopefully this is working out just fine. We'll see how this does. I'm sure a lot of people are going to go home tonight, probably Saturday night, look up the link, and go ahead and just revisit the entire episode.
Right.
Okay, because it's math, and what are you going to do on a Saturday night besides that? Right, right, right. You got me? Okay, okay. But let's go ahead and take a look. I want to just talk to you about data analysis and collecting data because some of you are ultimately going to decide whatever your topic may be to go ahead and collect your own data. Maybe you'll collect your own by using a survey, whatever it is you decide to do. Some folks, depending on your topic, you may go ahead and visit sites that have already accumulated the data. Like maybe if you're doing something nationally, as far as population, maybe you want to go to the Census Bureau. Uh, there's all kinds of resources available out there. And if you're looking and having trouble, just come to me. We'll see what we can do, see if I can help you find some that meets your needs. But this is not going to go into any big depth, because it's not a stats class. And I mentioned this a couple of days ago. The way we have IB here, I kind of think of it more as a little buffet. You're going to get a little bit of everything. The topics are going to be varying pretty widely from time to time, but we're not going to really go into a whole lot of depth. Okay, unless you want me to, like there are going to be times when I can go ahead and prove, what we're doing, the whole why behind it, but I never really saw the reason or, the justification for making it a proof course unless, is that something you folks would be interested in? Okay, so a couple pictures shaking the head no. If you do, just let me know. Okay, so let's see what we got here. Planning and conducting a statistical study. Understand the nature of the problem. What's the goal? So a lot of this is really just to kind of engage you and get you to thinking about your topic and what kind of data you're going to need to kind of move your point along, because you want your paper to flow nicely. Where can I go? How can I get that? What are some things I need to go ahead and look out for? Deciding what to measure and how, define the variables to develop the methods for determining their values. Then this is very important. You'll notice it's bolded, data collection. Does the data that already exists work, and is it enough? And that's a trap that some people fall into. There may be sites that have data readily available for your topic, but does it fall into this criteria? Is it enough? I mean, is it valid to begin with? Is it a reputable source? Okay. Does more data need to be gathered? Okay, what plan will be used to collect the new data? All right, so things to keep in mind while you're going through this. For data summarization and data analysis, graphs are a very excellent way of visualizing your data to help the reader see what's happening. But really, you're wanting to analyze the data using different strategies. And in here, it could be anything from what we're going to call the chi-squared test for independence, or it could be something very simple that you already know of from previous classes. How many people are familiar with the box and whisker plots? You guys remember those? Maybe, kind of, sort of. What about stem and leaf plots? Does those sound familiar? Okay. Typically not so much stem and leaf plots. I would say, if anything, probably the box and whisker plots would be more beneficial simply because you break the data up into, does anybody know? Starts with a Q. What's that mean? Oh, not quadrants. Very good word, though. Quartiles. Does that sound familiar? No? Okay, let me go ahead and draw one real fast just to make sure. So you typically see a box like this, okay, and then you have what could be considered your outliers, okay, the minimum value, the maximum value, okay, so this would be the minimum, this would be the maximum. Okay, right here we have the median, what we call Q2. What's the median value of a set of data?
It's the very middle one.
Okay, it's the middle value. Okay, when you go ahead and put them in order, okay, it's the middle value. What if there happens to be an even number of terms? How do you get the one median?
Average the middle.
There you go. You take the centermost values, you go ahead and average them. What are the other measures of central tendency you'd already probably be familiar with? Another word for average? Mean. Okay. Hey, thank you. Let's see, Libby. Okay. And Megan. Megan Mays. Okay. Michelle. All right. So there you go, ladies. And see, this is also another reason why I go ahead and record. So if you do happen to miss part of class, I know what these ladies are doing Saturday night. Yeah. Well, I was going to say you're going to get on the website, watch the sections that you missed. There you go. I believe so. I believe so. Ms. Jackson asked that happens as timely as possible. So if you go down there, it shouldn't take but a few minutes and get you right back up here. Okay. But we break these up into quartiles. We have Q1, Q3. Does that look familiar, those types of graphs?
Yeah, a little bit.
Okay. And I'm going to show you how to create those. And remember, it's like I said earlier in the week, I'm going to be showing you how to do these by hand, because I think that if we focus just on the technology, you're able to use the calculators on both paper exams. I just think that there's something lost. Okay, I think that you make a better connection when you're able to work this by hand as well. So we'll do it by hand as well as on the calculator. Okay, but you know, box and whiskers. Maybe some folks can help me out. Help me out. It's whiskers. You get it? Come on, are you kidding me? It's going to be a long year. Just get ready. Okay. There we go. All right. Moving forward. Hillary thought that was hilarious, didn't she? I could tell by the look on her face. She's going to laugh later. Formal data analysis. Apply the appropriate inferential statistical methods. The interpretation of the results. That is a huge criteria on the IA. Your conclusions. How do those conclusions inform us? And even if the data doesn't seem to support your topic, I would encourage you to embrace that. I think that's going to make your paper better. You know, based on the data you collect, regardless of the source, whatever your topic is, you know, it's really, from my point of view, the mathematical processes and results you get out of that. Does that make sense? Okay. How can the results guide future research? And we also talked about validity. That's really just kind of a reflection. And again, I'll talk more about these in detail as we go through the year. But that criteria is only worth 1 point. So it's either you're given credit for it or you're not. So I see it as a type of self-reflection. That's a time for the author to kind of think, did I actually collect enough data as a sample to represent the population? Was it good data? Did I collect it in a way that minimized bias as much as possible? You know, just things like that. Okay. Is there anything that could have been done differently that you did not do? That's really what we're looking for when we talk about validity. All right. So let's see what we got here. Sampling. Why risk making a mistake with a bad sample? Why not just poll, ask, or test the entire population that you're interested in? All right, so we're going to go ahead and do just a quick comparison here. We're going to get more into this on Monday when we start looking at the process. But the most common reason for having a sample instead of taking a census of the entire population is, and I've got pros and cons here that I'll go ahead and scroll down and let you see in just a second. But when we're taking a census, that's what we refer to as a complete enumeration.
So everybody.
Everybody. That means whatever it is we're talking about, people, units, whatever, we're including the entire population. So a sample is just a subset. Okay, it's a group within a group, okay, that we have. Like here, we're the only students, the 25 of us that belong to Math Studies 6th period at Lubbock High School, but we are one group, correct? So this group, we're called a subset. We're a smaller group contained within a larger group because we all still belong to what? Yeah, Lubbock High. We're all Lubbock High students, but this is a group contained within a much larger group. That's what we're referring to when I say subset, and that's a sample. That's a sample. Well, hopefully you choose enough to go ahead and represent the entire population so that you don't have to. Like if you are going to do your topic on the school, I would want to make sure that you have enough students. Does anybody know what roughly what our population is right now? A little north of 2,000, about 2,050, I'd say. So you're really close. So if you're going to go ahead and do something as far as the entire population of the school, you're going to want to get probably a good amount of data. You're going to want to get probably a large set. The way it's been done, you know, and then you got to think about, do you want to group all the classifications together? Or maybe do you just want to look at the freshmen, the sophomore, or juniors? Because if you're looking at the entire school, you're going to be putting all those people together. And for whatever your topic is, does one represent the same interests of the other? Everybody kind of see where I'm going on this? So there's always a lot of things to think about when you start looking at this. Okay, so a sample is what we call a partial enumeration because it's only a smaller group within it. All right, so we have this here. We have pros and cons of a census, and then we have pros and cons of a sample. And you know, just some that might leap to mind when you're thinking about this, just the time, effort, in a lot of cases, the cost of trying to take data from an entire population, which is why sampling is probably a preferred method. But even cons of a sample, the data may not be representative of the total population. Okay, as the data is collected from a subset of units and inferences made about the whole population, the data is subject to sampling error. And there can even be errors, what we call different forms of bias, when you're collecting the information. We're going to talk about it again today, but I think we brought up an example, was it yesterday? About just say doing some kind of survey, say on the tech campus or at the South Plains Mall, because you're excluding people who don't go to tech or who don't shop at the mall. Okay, and they can still represent the population. Now, this wasn't on your paper. Would anybody like to jot those down? Or, I mean, you could always just go to the website, go to the video link, and then just pause the video, I suppose, if anybody wants to do that. Does anybody have any questions so far? No? Okay. Well, let's see what else we got here. Now, this is kind of out of order, but I'm going to go ahead and talk about bias in sampling, and then I'll go ahead and start talking about some scenarios. We'll start talking about how to sample as well. So let's see here. Bias in sampling results in the tendency for a sample to differ from the corresponding population in some systematic way. And then I've got some different methods for you here. Selection bias, under coverage. When the way the sample is selected systematically excludes some part of the population of interest. In fact, what we were just talking about with Texas Tech and the mall, that's selection biased. Okay. Using a phone book to choose those that are in a sample of people in the city, that would be an example of selection bias, because from that example, it appears to me like you're just opening a phone book and randomly choosing people out of it. Okay, you don't know about their backgrounds, who they are, ages, or whatever it might be as far as your topic goes. Measurement or response bias tends to produce values that systematically differ from the true value in some way. So this is if while recording your data, you know, sometimes in science class, you'll do these activities where you have to measure or weigh, things like that. What if the scale is faulty? Okay, well then what happens to your data? It's not correct. But you could do this, and I've seen people do this. When they've been collecting material, they didn't realize until later on that there was some kind of fault within that system. But then you can still kind of embrace that, because you can go with validity on that. That's one of the criteria. You could say, even though I realize that there was this particular bias that exists, I can still probably at least, let's say something in particular about it. Let me go ahead and put it that way. Okay. Now, me, I'm just the type of personality where even if I go to the trouble of collecting all this data and then I go back to find out that one of my measurement tools, survey or something, had some kind of flaw, I personally would be compelled to go back and just do it over again. Okay. But, you know, people are different. You can do whatever you feel is best for your paper. Non-response biased. Responses are not actually obtained from all individuals selected for inclusion in the sample. Just because you walk up to someone in a random location, will they talk to you? They might just, you know, keep walking. Okay, so that would be non-response. There's also another one that comes up. It's mentioned here, but I didn't list it here as a biased. Convenience bias is when you would just say talk to your friends in collecting data, but you're not talking to anybody that you don't know. That's another one that could come up. And what falls under those categories: mail surveys, telephone surveys, somebody will randomly call your house, you know. The most important thing when taking a sample is that it must be representative of the population. Okay, so I want the city to create more bike lanes in Lubbock. I feel that I'm on a suicide mission when riding my bike through town on the way to school. A friend of mine said it best: drivers in Lubbock treat cyclists like jackrabbits. So I'm going to go to the city council and make a request that we need more bike lanes, that it would actually benefit the city of Lubbock. So I'm going to interview students at Texas Tech University for my research, and I'm going to stand next to the bike racks and ask cyclists what they think of the safety of cyclists in Lubbock. Are there any problems with this? Eli?
He's limiting it to only people that would see that there would be an issue with safety and cyclists and levels.
There you go.
Talking about like because they're cyclists, they're going to feel that there's an issue.
So which of the biases? Which of the previous listed bias, I'm not an English teacher, so I don't know, that we talked about, would you say this is? Yeah, let me go back and I'll show those, yeah. I'd say selection, because not only we talked about, he's just going to the Tech campus, but he specifically said, what was he going to do? Okay, the cyclist, he's just going to be standing by the bike racks. So even if a student does attend Tech, what if they don't ride their bike? What if they do have a vehicle? Okay, so that's selection bias. There is also another problem with this. Does anybody remember the old show? I mean, this is way before your time, but maybe you've heard of it. Just the Facts Man? Do you remember that show, Dragnet? Old cop show with a very serious cop. He would always say, just the facts. Well, is there anything in here that probably could be omitted? There we go. Drivers in Lubbock treat cyclists like jackrabbits. Okay, you don't want to put anything personal into it. You don't want to put any quotes or information that may lead the person to answer in a way that you're hoping they will. You just want to go straight to the point. Does that make sense? Okay. You don't want to try to influence their answer in any way, because that, of course, is going to skew the data and you have bias. Okay. So we've definitely noted there's some problems with the plan. Will my case be convincing to the city council? I would probably say not, simply because of the people that you polled for your survey. If this is what's presented, somebody's really going to be looking at that particular statement as well. Okay. Any other thoughts? Anything else anybody wants to add to it? No? Okay. Okay, so some sampling methods. Let's see, random sampling. When sampling, it is very important that it's done randomly. So this is what we call SRS, a simple random sample. SRS, a sample chosen using a method that ensures that each different possible sample of the desired size has an equal chance of being the one chosen. And typically we use the letter N to identify what size the sample is being used. Okay, and you've seen that in mathematics. Do you guys remember the summation sigma symbol? Okay, typically a lot of times you might say N or you might see it as K, but N is what we like to use as the population. Okay, so let's take a look at this. Suppose a class is made up of 100 students, 60 of whom are female. A researcher decides to select 6 of the female students by writing all 60 names on slips of paper, mixing the slips, and then picking 6. She then selects 4 male students from the class using a similar procedure. Is this a simple random sample? What do you think? Yes or no, based on the definition that we just read? Eli, what do you think?
No, I don't think so.
Okay, why?
Because she's just like treating like the females and the males as like 2 separate parties. It's like you're making it less random, I guess. Like
That's exactly right.
random, but it's not
This isn't completely random because she categorized them. She separated them specifically by gender, the 60 female and the 40 male. Okay? So it is not an SRS. It's not completely random. But now, is it a bad sampling method? There you go. Why would there still be equal representation? Does anybody notice what I wrote?
10%.
10%. Where's that 10% come from?
The 6 out of 60 and the 4 out of 40.
There you go. Even though there are 60 females and 40 males, okay, the number of each she's choosing has equal representation. Okay, 10% because 6 names are the females, another 10% for the 40. Okay, so I wouldn't say it's altogether a horrible method, but again, just things you want to keep in mind when you're doing it. Like again, if going back to the example of Lubbock High, let's say, you were going to go ahead and take 50 random classes, okay, and then for your SRS, okay, once you've collected 50, you just take maybe 3 to 5 of them, just chosen randomly, okay. That could work. It could fall under an SRS, but what would you want to make sure is going to happen with those classes that you chose? They should be what?
Classes that anybody can take.
Classes that anybody can take, okay.
Like some of your classes, like since like nowadays, like some of your classes could have like solely IB students.
Mm-hmm.
So you're not really getting a true representation like everybody who's.
And there you go. You want to make sure that they're somewhat similar because you're trying to say that they represent the population, right? So classes that are radically different, and it really comes down to how you even chose those 50 to begin with. Okay, it could be by subject area, could be by classification. I mean, there's a ton of variables to think about. All right.
So like essentially when like taking like samples like this, should we essentially look for like eliminating the most amount of variables we can?
You know, I mean, I've had some people who would collect pages and pages, just a huge amount of data. And some people worked with it very well, and some people, there was just too much data to analyze. So I guess it really depends on your own personal preference. How it affects your topic, okay, is really what I think it's going to come down to. I don't think there's really one like general answer to it. But as we go through and I give you more feedback based on your topic, I could probably say, you know what, I think this is really good data, but I think maybe you need more. Or maybe you have enough. I think you've collected enough, but maybe we need to refine it somehow. Maybe it just doesn't click with your topic just yet.
So maybe what we should do is like look and talk to people who could like best represent like everybody who lives in Lubbock. Like if we were to do a sample of like the city of Lubbock.
Okay.
So like would we essentially try to reach like the most amount of people with like, I don't want to say like different backgrounds.
Yeah.
But also that kind of thing.
But I guess, again, I think it depends on what you're choosing. I mean, because there's all different kinds of ways that we can compare people across the boards. Like maybe, you know, we're talking about population, maybe we're talking about economic background, maybe we're talking about level of education. I mean, see, from there, once you decide that, then you start to get an idea about how you could possibly collect the data and get that representation. So you want to refine, you know, what it is. What's the core group that I want to represent? That's what I'm looking for. Okay. All right. To conduct an SRS, create a sampling frame, make a list of everyone's name or number everyone's name, randomly select from that list with a random number generator. And I can show you how to do this on your calculator. It's one of the items coming up. I'm not sure when, but it definitely will. Then you can shuffle the names. Go ahead and choose those. Now, sample with or without replacement. That's important. You could potentially put the names back if you wanted to. All right, I guess it just depends on your situation. I would probably not worry about that, but that's completely up to you. Random sampling is a reliable way to represent even a large population. The larger the sample size, the better, but surprisingly, it does not have to be a huge sample just because the population is large as well. Now, there are formulas that go with these where you have your initial amount, your hypothesized value, but there are kind of a lot of jokes that go around, and maybe you are or not aware of them. I am more aware of them because I am a math teacher. But for a statistician, an answer close enough is more likely going to be considered all right than one of the other mathematics that we have out there. Like, say, calculus, close enough is probably not what we would be going for. We'd want a more accurate, approximate answer. Okay, like a magic number in statistics is going to be 30. Okay, when you're using sampling and things of that nature. Okay. All right, stratified random sampling. When the entire population can be divided into a set of non-overlapping subgroups, this method often proves easier to implement and more cost-effective than random sampling. So what I wrote here was the example of a classroom. Maybe you go ahead and divide all the students in the class into 2 groups, and then out of the 2 groups, you randomly choose 5 people or so. Okay, that's what we're talking about. Cluster sampling. To select groups of individuals from a population, that is to select individuals themselves, dividing the population of interest into non-overlapping subgroups called clusters. Clusters are then selected at random, so groups themselves, and all individuals in the selected clusters are included. So the whole groups are chosen here, That's what's chosen at random, not the individual people. Okay, so maybe you're to walk into a classroom, and I don't know how it would work with a classroom this size. You definitely want one larger. But if you just randomly made, I don't know, 5 to 6 groups, and then you just chose from those 5 to 6 groups, maybe 2 or 3 that you're hoping is going to represent the population. Okay. And the one we don't have to worry about here is systematic sampling. I'm not even going to worry about going into that. I think, yeah, that's pretty much it right there. Okay. So I'm hoping this kind of gives you an idea, just a kind of techniques that are available out there. I mean, there's a ton more. Please don't believe this is going to be it. Like I said, this is just going to be a broad overview of some topics just to kind of get things going. But, take this weekend, really just try to think about what you're passionate about, and that's what I recommend. Okay, choose an IA topic that you're very passionate about, that you actually have some kind of investment in, because from my point of view, if that's the case, then it's not going to seem like work. Okay, you're probably actually going to enjoy it. You're going to want to figure out what your results are going to be, and I mean, it's mathematics anyway, so you're probably going to want to do it anyway, right? Right. What's that?
IA.
There you go. I can already see the title page now. IA, the IA. There you go. Mind blown. Okay, so let me go ahead and move on to that other paper that we have here. Okay. Oh, of course I did not erase it. So avert your eyes, children. Pay no attention to the man behind the curtain. Okay. Hopefully one of you gets that. One of you is wearing a Wizard of Oz shirt. Right? There we go. Okay. There we go. All right. So I do want to go ahead and talk about sig figs, and I thought I'd just go ahead and throw this in because we might as well go ahead and talk about it now. Our hierarchy of numbers, how we classify them. What were the first numbers, your counting numbers, that you ever learned when you were in school? Okay, 1, 2, 3, 4, 5. Do you remember what we called those?
Natural numbers.
Those are your natural numbers, okay? Now, in IB, it's going to be a little different. We don't refer to them as natural numbers. We still use n to represent that set, but in IB, we call them cardinal numbers, okay? So we call them cardinal numbers. Now, the natural numbers were a subset of what?
All real numbers.
Yes, but there are more subsets as we get larger. Whole integers? Yes, there's just one part you don't need right there. The integers. The whole is correct. Okay, so let's do this. Okay, and I'll just go ahead and do it right here. Maybe it would be easier if we worked from the top down instead of just the bottom up. Any number that you ever come across can be classified as what? It is real. Okay, now the reals are going to be broken up into 2 subgroups, 2 categories. The rational and the irrational. There we go. So, I don't know why I did that. Oh, I put real. Q is the letter that we use to define the rational. And typically when you start getting larger, because the reals are a subgroup of an even more larger group that we call the complex numbers. You guys remember imaginary? Like the square root of -10, things like that. When you start creating the hierarchy and making it larger like that, you want to use a different notation, but for our purposes, I'm just going to go ahead and put I for irrational. Okay. Now, what was the difference between rational and irrational?
Irrational like numbers like pi, stuff like that.
Okay, yeah. Pi is probably the most famous irrational number that we have. 3.141592653752984623. I can actually go pretty far. It's one of those party tricks that really doesn't do anything. Okay. But yes, so there are 2 conditions that have to be met if a number is deemed irrational. So think about pi. Okay, it is a decimal, but what do we know about that type of decimal number? It's infinite. Okay, so it never stops. Okay. And what do we see with the numbers, the values themselves? There is no repetition. There's no pattern. Okay, so it's a non-terminating decimal, and there's no pattern to it. All right. Now, on the other hand, Rationals have an actual definition. They can be written in the form a divided by b. Basically, it can be written as a fraction with the one restriction that b can't equal 0. Because what's the one thing you can't divide by? Can't divide by 0. Okay, it's undefined. All right. So now, if a number is deemed irrational, that's it. You're not going to be able to go any further. There are no subgroups of the irrationals. What's the first subgroup of the rational? Okay. Oh, now you're forgetting the other one you mentioned. Integers, which we use what letter? You can probably tell if you look up there. Z. Z are the integers. Okay. Then you have your whole numbers, and then you have your natural numbers. Okay. So the natural numbers are the first numbers that you ever learned when you were in school. 1, 2, 3, 4, and so on. What is the only difference? There is one element difference between whole and natural. 0. 0 belongs to the whole numbers, but it does not belong to the natural numbers. Now the integers, those are your positive counting numbers, 0, or 1, 2, 3, 4. It also contains 0 and their opposites. Okay, very, very important to realize that when we're talking about integers, whole numbers, and natural numbers, no decimals, no fractions. Okay? And then when we get to the rationals, we have fractions that we're allowed to look at by definition. And then, of course, everything's real. All right, so like I said, IB just kind of does it a little differently. Probably the biggest difference is that instead of calling it the natural numbers, what we're accustomed to, they call it what? Cardinal. Okay, so let's see here. Let's go ahead and create the hierarchy with what we have here, and we've got all these terms listed: negative integers, fraction, 0, irrational, integers, rational, and positive integers. Okay, so we just went through this. What do the real numbers break into? The rational and the irrational. So I'm going to say rational numbers. Rational numbers, so that's out. And then we have irrational. I'm going to start to abbreviate these. Irrational numbers. Okay. And I just realized that I wrote those backwards. Yeah, you know, when you see things like that, it's not so much that I made a mistake. I was just saying if you're paying attention. I like to keep you guys on the ball. Yes. La, 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 la. La, la. What's that?
I like to keep Skinner.
Oh, good. Rationals. Okay. Now the rationals break up into what? Okay. Well, look at what we have left. Okay. So definitely what's contained within the rationals by definition? Integers, but also something else. The bigger one I'm looking for is going to be fractions. Okay, so there's my fractions. And then, what's the other one? Integers. There we go. All right. There you go. And then I'm going to go ahead and abbreviate this. You can have 0 here. And instead of writing it out, what was the letter that represents the integer group? Z. Oh, Z. Q is the rational. So I'm going to go ahead and put Z, but where a power would be, if I put a plus or a minus, that indicates the sign of the elements we're talking about. So the positive integers and the negative integers. Okay. Good? All right. And this is what I really wanted to get to here. Now the measurement, this is kind of foreshadowing error approximation, okay, and accuracy. That's something that we're going to get into, later. So I'm not concerned with that right now, but let's take a look at sig figs. Significant figures are used to determine the accuracy of a stated value. Generally, the number of significant figures in a measurement can be found by counting the figures. Leading zeros after a decimal point or trailing zeros of numbers with no decimal place are not considered significant figures. Okay, so here's what I like to do. Let me go ahead and take this off. I'm going to use a little bit of room here. There's a ton of rules that go with these, and sometimes they can get a little confusing, and you can mix them up or possibly even misinterpret them. What I do for the number is think about, is there a decimal point that's present or absent? Okay, kind of think about it like you have America in the middle, And this is going to be horrible, but that kind of looks like America again, right? Okay. Well, if you want me to erase it, I can make America great again. Go on. Anyways, okay, so what ocean is to the east of America? The Atlantic. This is just a little trick I use, and if you're already familiar with sig figs, I get however you like it. So the west we have the Pacific. Okay, so what you're doing is thinking about the decimal. Either the decimal is absent for Atlantic, or it's present. Okay, and whether it's absent or present, that's the side you begin on with the number. You start counting at the first non-zero value. Okay, so like for example, let's start at 5,000. We're going to go out of order, but this one's kind of interesting. So I'm going to put 5,000 right here. Is there a decimal or no? There's no decimal, so I'm starting on the right side, and I'm going to start counting at the first non-zero value I get. 1. So 5,000 is only one significant figure. Okay. Let's take a look at A, 5,032. Is it present or absent? Absent, so I'm going to start counting from the right, but the last digit is a non-zero digit. Now, if you come across a 0 in the middle, if it's between two non-zero values, you still include that. So this one would be 4. Okay. 2,400 kilograms. That's 2 sig figs. No decimal, we started on the right. See how easy that makes that? Makes it super simple. Because a lot of times you're going to be asked and you're going to be given points on the paper exams. You'll still get credit for being close, but they might take points off if you don't give the correct number of sig figs. And what's the number they like if they don't say? We like 3. We like 3 sig figs. Okay, so what about 32,007? That is 5. Okay, and this one's different because D is the first one we've looked at that has a decimal. So where do I start? On the left, but I don't start counting until I reach the first non-zero number. So this one's 3. That trailing 0 would be included. It's a placeholder. Okay. So with that one having a decimal, does everybody get the point? Everybody get the point? Decimal point. Come on. Come on. Okay. What would you guys say to 6.016? That would be 4. I would start on the left side. There we go. And like I said, there are a lot of rules to accompany significant figures, but I like to make things as simple as possible. I live my life. There's no reason to make things more complicated than they should be, but you know, to each their own. Okay. What time is it? 2:06. That was perfect timing. We have about 2 or 3 minutes left. Does anybody have any questions? Anything we've covered today that we need to elaborate on? Anything I could do? Okay. Well, guys, thank you very much. Let me go ahead and stop.